We're going to look next at factoring a difference of squares, and we're going to begin reviewing factoring trinomials. So a difference of squares is exactly what it sounds like. You've got two numbers that are squares. Here, x squared is clearly x squared, if you wanted to think of it that way, and 25 is 5 squared. And they're a difference because there's a minus sign in between them, and we can only factor them using this method if we have all three of these things true. The first number has to be a perfect square, the second number has to be a perfect square, and there has to be a minus sign in between them. We can't do it if it's a plus. Now, once you've identified that it's a difference of squares, and you've identified what the square roots are, you're almost done. To factor a difference of squares, the pattern is you take the positive square root of the first number, or the first term, and you write that as the first term in both of the brackets, and then you take the positive square root of the second number and write that in both brackets, and then you write a plus in between them in one bracket and a minus sign in between them in the other. And it doesn't matter if you write minus plus or plus minus because the whole thing is being multiplied together, so the order won't matter. So that's how you factor a difference of squares. Let's look at a slightly more challenging example. Now we've got 9x squared as our first term, 64 as our second, and a minus sign in between them. Two perfect squares and a minus sign, so we can factor them as a difference of squares. Now, 9x squared is 3x all squared. So the positive square root of that is 3x, and the positive square root of this one, 64, whoops, is 8. So now, again, we write 3x as the first term in both of the brackets. We write 8 as the second term, because it comes from the second term here, and then we write a plus and a minus. And that's factoring a difference of squares. Now let's begin looking at factoring trinomials. Now there's several different types of trinomials that you should be able to factor. The first one we're going to look at has a 1 as the coefficient of the x squared term. So notice that we've got an x squared term, then we've got a term with an x, and then we've got a constant term. And those are the kinds of trinomials or three-term polynomials that we're going to be looking at factoring, with an x squared term, an x, and then a constant term. The variables could be different, but you'll still see this pattern of the exponents decreasing until they disappear. Now, it's important to recognize again that you've got a 1 here in front of this x squared, because the method of factoring we're going to review right now only works if there's a 1 there and not any other number. There's a different method if there's another number. Now that 1 won't be written there because it's just convention to assume, or to understand rather, that it's there if it's not written. Now, the way that we factor these is we're looking for two numbers that multiply to make this last number. So we want two numbers that multiply, in this case, to make -10, and add to make the coefficient of the x term in the middle. So in this case, we want two numbers that add to -3. So you might be able to come up with them off the top of your head, or you might find that it's helpful to list the factor pairs of this last number. So the factor pairs of -10 would be -1 and +10, or +1 and -10. Either of those would multiply to make -10, and then +2 and -5, and -2 and +5. So now we look down that list to find the ones that add to make -3, and it would be 2 and -5. So now we take two brackets, and we write x as the first term in each of them, and we write +2 in one and -5 in the other. And if you were to multiply that back out, you'd see that you get the above trinomial. Let's do the other one. We are looking for two numbers that multiply now to -42, so they'll have opposite signs, and add to +1, which is the coefficient in front of the x. You could either list the factor pairs or just think about it, and you would get that those two numbers have to be +7 and -6. So that trinomial will factor like that, and you could expand back to check it if you wanted to.